Okay, so in problem 36, we took our buffered solution from problem 34, and what we're doing to it is we're adding hydroxide. But the first problem that I see is that I don't have any hydroxide in the equation. So I need to think, if I put hydroxide into this container, where is it going to react? Basically, there's no H+. Okay, we're starting out with this and this initially. If you're thinking back to 34 and you're saying, Ms. Schleibaum, there's a little bit there, okay? It's, number one, it's pretty negligible. And number two, we're pretending that first it needs to react and then the H+ is going to come from the HF. So initially, we're saying no H+. So the hydroxide has to come over here. Okay, so we have the hydroxide plus the H are going to make H2O, which we never care about because this is liquid and all the others are aqueous. We're adding 0.1 moles of this. Now here I have 0.6 molar, but it's in a 1 liter solution, so it's going to be 0.6 moles. And this one is also in a 1 liter solution, so it's going to be 1 mole. Okay? So here we have our equation and we need to decide what to do. And if you see two things on the same side, okay, two concentrations on the same side, before you ice, you must Becca. Okay, so that's why I was setting you up to put it in moles. I should have told you that we were going to Becca first, but that's why we were doing the moles. B, C, A. I don't know why I circled that, but whatever. Alright, so if we look, we better lose all of our hydroxide first. Because if we don't lose the hydroxide, then our buffers, if we run out of HF before we run out of hydroxide, then our buffer has stopped working. Okay, so first we must lose all of the hydroxide. 0 left. 0.1 moles, and that's going to give me with 0.5 in here. Okay, we got to think, where's it going to go? The OH and the H are not going to make any H+. The OH and the H are going to make more water, but we don't care about the water. The OH and the H are going to go together, leaving us with F-. So we do need to add 0.1 moles here. So we get 1.1 moles of F-. Now we are ready to ice. So we divide again by 1 liter. And we go down here and we ice it up. 0.5 and 1.1 and 0. Okay, my change, let me put these on top for you. Okay, my change now is minus x plus x plus x. And I have my Ka equals 7.2 times 10 to the negative, I forgot it, negative fourth. And that is going to equal 1.1 times x over 0.5. We say neglect because 5% rule. And when we solve for x here, we find that x is equal to 3.3 times 10 to the negative fourth molar. So when we take the pH of that, we find the pH is 3.48. In the previous problem, the pH, oops, wrong one. The previous problem, the pH was 3.37, and here it's 3.48. So even by adding a decent amount of hydroxide, we didn't change the pH very much. Okay, I'm going to do one last one to show you what happens when we add H+. Okay.